Hi everyone. Welcome to Machine Learning Institute Certificate. My name is Ivan, and today is kind of introduction and attempt to explain the program, what we do and what we're trying to teach in this Machine Learning Institute. So we're going to discuss today MLI timeline. What should you expect in terms of your program? Sorry.
You can just try another one.
Sorry. We will discuss what techniques of machine learning we will learn in this course. Then I'll briefly cover the prerequisites for the MLI. And then we'll leave some time for questions and answers. So it's going to be a brief session, no more than 30 minutes. And the slides will be shared with participants later. So timeline of MLI. So we will start with Python introduction course, where we will cover what we need, what essentials of Python we need to know to start doing data science and machine learning exercises. Then we will go straight forward to the machine learning techniques. So in the first module is going to be mostly about supervised machine learning. Right? Supervised machine learning is the part of machine learning when we do have input and output, right? When we have labels of our inputs. And the goal of supervised machine learning is try to understand the mapping between input and output, trying to get this function. Yeah. Then next module number 2, is going to be about unsupervised machine learning. So when we don't have these labels, when we have only input data, what techniques we have in order to work with this kind of data. Then we move on to some use cases and try to cover what actually practitioners do in their research, right? What techniques, what are useful insights we need to do in machine learning, right? Because it's theory, but when it comes to practice, it's maybe very different from what people say in the papers. It's worth saying that across the whole this timeline and across the course, we will be trying to deliver practitioner approach, right? We will be covering a lot of use cases, a lot of different data sets. Yeah. So next module, number 4, is more on deep learning, when we introduced more advanced techniques, which are about neural networks. We will cover different type of networks, which type are used for which cases, as well as we will do some exercises and we'll cover these cases. Then we move on to even more, I would say advanced techniques, particularly to reinforcement learning thing, which is I would say quite separate from unsupervised and supervised machine learning technique. Then module 6 is going to be about time series, about forecasting. We start with quite simple models and move on to the more advanced models. And in the end, we will have the final exam that will cover all the modules. And also during the course, you will be asked to do some final project. Yeah. So the topic of the project you can choose yourself, depending on your interest, depending on your research, depending on your job maybe. And at the end of this course, you will also have to submit the final project. And along this line, after each of the module, you will have homework assignments. Yeah. So yeah, and let us now a bit dive into each of these modules, just to give you an idea what are these techniques. Right. First module is about supervised machine learning. So we will cover such algorithm as regularization, L1, L2 regularization. We will cover classification problem. We'll go deeper into random forests, support vector machine, and many others. Yeah, and also for each of the techniques, we'll be doing the practical examples, right? How to come up with a proper trading recommendation system, how to perform validation, how to perform predictions, right? And all these use cases will be performed on real data sets, right, with a lot of practical insights. Then a second module, unsupervised machine learning. We'll do the dimensionality reduction techniques, which are PCA and autoencoders. Then we'll cover clustering techniques, how we can cluster the data depending on the similarity within the data, outlier detection, yeah, so how to define the point which is the outlier. And also part of this unsupervised machine learning, we will do generative algorithms, for example, GANs, which is gaining popularity nowadays. Some practical examples from the course regarding unsupervised machine learning. So we'll do customer segmentation, right? How to better understand your customers. We will introduce you to NLP, natural language processing techniques, and try to automatically summarize some text, some blocks, some text data, stock segmentation, and bond yield curve dimensionality reduction. These are just some examples of what we are going to cover in this course. Then we move on to practitioner approach. I would say maybe this one is a key of the course, because these are techniques when you can actually extract some positive and good results from machine learning, right? How to perform cross-validation, how to perform regularization, how to choose the best model, how to evaluate model performance, yeah, and then how to choose the best model between different models. And then how to generate features for your model, how to extract features from the data. All of this we are going to cover in this particular module. And among some practical examples, we'll try to forecast bond prices based on the natural language processing techniques. We will try to do market impact assessment, and also we'll work some medical data and try to classify whether a person is diabetic or not. Yeah. So we are not really restrict ourselves to the financial data. We try to use these techniques in other areas as well. So a bit more on reinforcement learning and deep learning. So yeah, there are different algorithms in reinforcement learning, and hopefully, thankfully to the recent publications and developments by such companies as DeepMind, like Google, we have these nice libraries where we can actually play with these techniques. So we'll try to cover all of them. For example, we'll go to OpenAI library and try to balance this nice card poll, for example. Try to come up with optimal trading strategy for market making. So a lot of interesting use cases of reinforcement learning for this particular part. I personally really excited about this topic, and I like the idea that people nowadays doing this open source. So a lot of blogs, a lot of open code. So you can play around with all of this stuff. Then we will move to neural networks and time series forecasting. So we have different neural networks, and we will try to understand which particular neural net works for which case. For example, we will cover convolutional neural networks, which is primarily used for image classification and working with images. Some neural networks used for time series, which are LSTM and recurrent neural networks. And we also cover different techniques which used for working with neural networks, such as backpropagation, optimization, because these are really complex models, and to find the optimal parameters of these models, it requires knowledge of some of the techniques. During the course, you'll get a lot of different materials. Obviously, firstly, it's lecture notes for each of the lecture you'll have during this course. Then there will be some video recordings. Yeah, so you don't have to be present. You can watch it online over weekends or whatever, whenever your time permits. And also, practical exercises. Whatever exercise we do, and try to code something, we'll try to do in Jupyter notebooks. Yeah, so and they will be distributed along with lecture notes. All the data sets that we're using, and if they are not open source, we will also distribute so you can play around with them. And also in the very beginning of the course, you will have the Python thing, right? But also you will get the presentation on the prerequisites you need to know about the course, such things like linear algebra, statistics, theory of probabilities, optimization theory. Yeah, and these are maybe the general list of topics one ideally would like to study before joining such a course. So linear algebra, definitely yes. Optimization theory, probability theory, statistics, and Python programming. But Python programming we will try to cover at the very beginning of this course. For the rest of them, you'll get the materials, but ideally one would like to understand and know this something about this for math areas in advance. So yeah, this is I think for introduction. Happy to answer any questions on the materials, on the coming structure of the program. Please welcome. Please type your questions in the chat if you want to.
I've got one. So I read in the brochure that it was focused around finance.
Yep.
So will you need a background in finance to be able to get through I saw the final module and the earlier versions was finance-based. So
yeah, even though maybe it was written as finance, we will be using different data sets. And if there is some particular concept in finance that requires some explanation, we will explain what does it mean. So there is no requirement to have a financial background or so.
Okay.
Yep.
So how in-depth do you need the knowledge of the prerequisites?
Yeah, it's actually a very good question. Yes. I would say ideally first 2 years of university would be enough. Yeah, but obviously many people finish these universities and graduated like maybe 10 years ago or so, and these techniques may be so. In order to understand them, you need kind of to practice, right?
Yeah.
But for this course, we will first distribute materials that briefly describe the set of topics you need to know. Mm-hmm. Yeah. So even if you forget something, you can look up at these materials, and maybe if you don't know something, maybe you can look it up further, right? Mm-hmm. But even though if we again if we use some advanced technique, let's say from statistics, let's say we're saying we have a covariance matrix, right? Obviously, we first introduce what covariance matrix, and we'll try to explain how what does this mean, and well, how can we estimate this matrix. So whenever a new technique we encounter in the course, we'll try to introduce it. But at the same time, there is requirements to have some basic knowledge, right? Like what is a vector, what is a matrix. So such things would be good to know before joining this course. And regarding the coding skills, a Python programming introduction course will cover all the basics of the Python. So if you don't know or didn't have experience in Python before, so don't worry. We'll try to cover that and introduce you to Python.
And the final project at the end,
yeah.
Is that entirely coursework, or is that an exam, or?
So the final grade will consist of 3 pieces. First one is your homework.
Mm-hmm.
Yeah. Homework will be distributed after each of the modules. Just to remind you, there are 6 modules in total, and after each we will have one homework assignment. So this is one piece of the exam, of the total mark. Yeah. Another piece of the total mark is your final project,
mm-hmm.
and the last piece is your final exam. Yeah, and the weights are equal for these 3 pieces. So with regards to your final project, you can choose it anytime, but you have to submit at a certain date. Mm-hmm. Yeah. So ideally, this project should cover some of the topics, or should use some of the techniques that we introduce in the course. Mm-hmm. But the data sets or the topic you would like to do is not restricted. It's up to you to choose which data sets you would like to play with, what problem you would like to solve, up to you. And in the end, ideally, you would like to submit your paper, right, your comments and your approach, and then code as well, right, just to prove that you've done it yourself, ideally in Python. Mm-hmm. Yeah.
What is the minimum mark to pass?
I guess there is some information in the brochure, but I think minimum mark. So there are different minimum marks. So for exam, 50% of the questions you should answer correctly, at least. And then for project, you also have to. Maybe I'm mistaken, but you also have to get more than 50. And overall, and then we just weight all this. But there is no requirement for overall. So as soon as you pass exam and as soon as you pass your final project, you can think that you are pass. You can get this certificate.
So interesting. How is it compared to the CQF, right? Certificate in quantitative
mm-hmm.
finance.
Mm-hmm.
Are other? I mean, it's been sold as sort of postgraduate qualification. Does it have any associations with, let's say, universities or things like that? And its accreditation, and more importantly, like let's say if I have a CFA, then can I use parts of it for my continuing professional learning and things like that?
Mm-hmm. I don't know much about CQF and machine learning in CQF.
Right.
So,
right.
But what I can tell that this course is not restricted to finance only, mm-hmm. right? So even in this presentation, we've seen some examples which are not from finance, customer segmentation, or balancing the pole, right, which is like very generic approach, yeah. And then constructing decision tree random forest for diabetes disease, right? So medical data, some images, not necessarily from finance.
Right.
So I would say this program is quite generic. We'll try to cover different data sets. And also in terms of connection to universities, some of the instructors are actually researchers in the universities. Hope it answered your question, yeah. But I just don't know much about the QF program.
A question about the model that forecast the time saving.
Yep.
Generally you should forecast Y related to X. features.
Yep.
But generally in T+1, you don't know the X
Yep.
in the future. How do you in the model?
Yeah.
If
Yeah. Well, it's already we're going to the course, but
I put the question right. I don't know.
well, but you train your model on historical data,
Yes,
right?
If you want to forecast in the future,
Yeah.
you need a new set of data.
Right.
You don't know.
This is what we need. Why we need this splitting in machine learning. One of the key concepts is cross-validation. Right. When you split your initial data, so you have this bunch of historical data, right? You say I want to train my model, and I split my historical data into training set and validation set. Let's say there is normally also additional set which is called test set. Right, but let's assume we have training set and the validation set. And what you do, you pretend that you don't know your validation set, right? And you train your model on training set and estimate.
In reality, it's not like this. You know,
Yeah.
I keep all my data. I'm using all my data as a training set.
Yeah.
You know, and I want to forecast for
Yeah.
a new data set, but I don't know. You know.
No. What I'm saying is that you train your model on training set and evaluate your model performance on validation set.
I know this, but
Yeah.
in reality,
But
you should forecast on the new data, you know, but you don't know the new data, that's the problem.
and then when you train your model, you deploy in production and try to see how the model behaves.
The problem is, right, when you forecast time saved, you know.
Yeah, well, I agree with you. The key thing in machine learning is data. Yeah, how much we have, how clean it is, and well, with forecasting.
There are econometrics models that put X in T-1, and if you forecast X that is at T-1, you at T+1, you forecast X at T, do you know, and you could forecast Y T+1, you know.
Yeah, but again.
But this is different than econometrics model.
Machine learning, how machine learning is different from econometrics? It's focused on prediction, but focus on how good your model is on out of sample, on the data which the model didn't see yet, right? So that's why we're kind of pretending that some data is unknown for us, and we'll try to evaluate our model on that data. Any other questions?
So interesting. What, this is the third one of these, right?
This is cohort 3, yeah. Yeah.
The profile of candidates, what have they been doing? You know, are they more from sort of, you know, corporates, from banks,
Yeah.
from finance, and
Yeah.
you know, what's the split?
I would say people are from corporates, but not necessarily from finance. I would say a lot of people from finance, maybe from 30 to 50%, right? But it's not necessarily from finance.
Right.
What also I know, well, these are they are professionals, right? So they are most of them are professionals, but some of them are quite young. They're just students. So.
Okay. And what sort of each cohort is how many students all in the total?
I'm not sure about this question. So yeah, I'm just maybe to cover my responsibility in this course. I'm helping with the content of the course, right? I'm delivering the lectures. So about administrative thing, I'm not really best person to answer these questions.
If you could be about 20 or 30,
Okay.
but actually in the room will normally be something like this, about 3 people.
Okay.
Everyone else is watching online.
Okay.
So cohort 2 was like
I think there's over 20.
20.
Obviously, I only see people online at any one time.
How does it last, the program, or how does the program last?
So it's in total 6 modules. Each module is about the 3 maybe 4 lectures, 1 lecture per week. So it's regarding it's about like 6 months in total.
And where is those, like in the class, is it here, literally here?
So yeah. In the day of the lecture, you have several options. You can come to this class. It's going to be on Tuesdays. And or you can watch it online. And the good thing about watching online, you can type your questions, right? And all the lectures will be recorded, and you can see links to the videos after the lecture.
And are these lectures available, for some time, or do they get? I'm just trying to work out that, let's say 6 months later, I want to go and read something. Are they available, or do they get wiped out, or do we have access to these lectures in future?
I think we keep the the online resource open, and you will forever be in that cohort, so you can go back into it.
Right.
But I need to check how long will you go open for.
So definitely for the duration of the course, you will have the links to the videos. But
obviously we put the resources up, so you just download them all.
Oh, yes. Yeah. Okay. Makes sense. Yeah.
Yeah, in case, yeah.
So how long are each of the lectures? A couple of hours? Or
So it depends on the instructor, but it's maybe from 1 hour to 2 hours max, right? So with an average 1.5.
And how much self-study would we be expected to do?
So after each, so self-study will be required for homework assignment, mostly. Let me give you maybe examples. So we have for current cohorts. Yeah, we are starting. Yeah. For current cohorts, we have module 3, and there are 7 questions in the homework assignment. I would say that would require you in total, maybe depending on your skills, maybe from 1 hour to 3 hours.
No question.
No, for total assignment.
Right.
Yeah. So yeah, in case you will have some questions during the course about material, about the assignments, about projects, whatever, there will be a forum in the website where you can post your questions and ask directly instructors if you're unclear about something.
And actually, maybe just following on from that course material, are they based on specific sort of books, or is it pretty much what lecturer comes up with the course content, or?
I think more or less you can see what is the exact content and what is the exact topic in the brochure.
Okay.
So it's unlikely that something will change, but who knows? Maybe.
Yeah.
But we keep it. We try to keep it constant.
Okay.
Yeah. Cool.
Is it an introduction for new?
Yeah. Sorry. We will start maybe in 5 minutes. No, you didn't miss anything. Okay. Any questions on the chat?
No.
Okay. Then thank you very much. Thank you for your time.
And are you